Actually, I prefer to give people something interesting to look at rather than sitting and. Schedule a meeting. Forget it. Forget it. Okay. The other downside of using my own machine here rather than my demonstration machine is that you get to see my schedule and mail and everything while we're giving the demo. But we'll get through that. Okay. Make sure this is on. Okay, great. Finally going to get started. Thank you for your patience in changing rooms and all the delays here. I hope the demos and everything you see will make it worth it. So my name's Jacoby. I'm the program manager in the speech technology group here in Microsoft Research. And today I'm going to talk to you about a product called MiPad, which is a voice-enabled PDA. I'm going to tell you a little bit about the speech technology group so you've got an idea of where this is being developed. Then I'm going to give a bit of an introduction to MiPad, kind of our goals in the project. It's a little bit different than most Microsoft products in that right now it is internally focused. We're going to be deploying this at Microsoft, not across to the rest of the world, and at least not initially. And so have a little bit of different goals for the project than most products. I'll share a little bit about that. The exciting part, I'm going to give you a MiPad demo towards about the middle of the talk here. Talk a little bit about the technologies in MiPad, and then talk about some of the things that you might want to think about in applying speech recognition to your products. And then leave a lot of time for questions here at the end. I want to treat this fairly informally, so if you have questions as I go along, please feel free to stop me there as well. So, STG, the Speech Technology Group. Basically, our mission is to develop best-of-breed spoken language engine technologies. The Speech Technology Group is where the Microsoft Speech Recognition Engine was developed before it moved back out to the product groups for productization. And really, that's where our engine research is going. Going on, rather. The other thing that we're doing in STG is working hard on user interaction models for speech recognition. That's really where my focus has been recently, is trying to develop user interface models for speech recognition that are really compelling. And then finally, as part of STG's mission, to help integrate speech into Microsoft products. And so, of course, that's a large reason for the talk today, is to try and get all of you aware of what we're doing in the Speech Technology Group and thinking about how you can use speech in your products and migrate it out to our commercial offerings. So, STG is a fairly small group. We've got about 17 people. 10 of those are researchers. Primarily, it's a research group. MiPad is more of a product effort that we're spinning up in STG, and so we've added myself and program management, a couple of developers, a couple of test folks, trying to ramp up on MiPad. But mostly, it's researchers in the group. In terms of history, the group was started in 1993, and then in 98 split off into a product group side and a technology group side. So we're the technology group side in research. The majority of the group went off to the product groups in 98. And MiPad is the primary project I'm going to be talking about here today. Of course, there are other research projects going on in STG. A more general talk about the group as a whole could focus on those. I'm going to focus primarily on MiPad today, though. So, this is a demonstration application. It's more than a prototype. You may have seen a lot of projects come out of Microsoft Research that are really just one-off prototypes, demonstrating an idea, but not a whole lot else. This is not MiPad. MiPad is really designed to be something useful, something people internally at Microsoft are going to be using every day once we roll out and deploy. So it's certainly not just a prototype. It's somewhat less than a full product, though, in that we're not right now planning on selling this outside of Microsoft initially. So the goals of the program, first of all, to create a compelling interaction model. This is one of the things that is really near and dear to my heart. When you've got a PDA that's running around with you all the time, it's really interesting to figure out when it's socially okay to talk to it, when it's not socially okay to talk to it, and just create an interaction model that's really useful instead of getting in the way. The other thing is that there are some very definite barriers to the success of speech recognition applications in the marketplace today. If you've used things like Dragon Naturally Speaking or some of the LNH speech recognition applications, the experience is interesting. There are definite benefits to it. You can see situations in which you would use it, but it's also got some deficits. It's kind of hard to do error correction. It's not very good at noisy environments. It's kind of slow. There are certain barriers in the technology to speech recognition being really as useful as it could be in products. And so one of the goals of MiPad is to have a concrete, complete enough product that we can identify where these barriers are, so as to provide direction to the researchers and what problems are most critical for them to be solving. Next, we want to collect real-world data on speech usage. There isn't a whole lot of PDA mobile environment speech data outside the labs today because there aren't too many commercial products that are trying to tackle this space. And so getting an idea of how people really use these things, rather than how we postulate people will use these things, is really critical. And so one of my goals for MiPad is to do some long-term longitudinal study of users to see how they're using them as part of their everyday work life, to try and validate some of our design assumptions in MiPad. And then finally, to transfer the ideas to the product groups. And when you have a concrete application of research ideas, a lot easier to show people how it applies to their product, how they can use it. Some of the positioning stuff here, MiPad is really targeted just towards job functions, professional life. Maybe spills over a little bit, you might take it home, but you lose speech when you take it home. Because today we need the wireless LAN connectivity in order to do speech recognition on your pocket PC device. And so the requirement that we have that wireless LAN there really ties you pretty much to work where we've got the wireless LAN deployed, unless you deploy a home LAN and use it on that network. But really, we're talking about a device that will help you here at work at Microsoft in your professional life and not spilling over to the other places that you might use a PDA initially. So why did we choose PDAs for doing speech recognition on? Basically because of the input problem. If you've looked at or tried to use a Palm Pilot or a Pocket PC, any of the PDAs very much recently, you'll have realized that data input is a real problem. Touching that little on-screen keyboard, typing on that, you don't get very good input rates. It's not a very attractive experience. It's really pretty frustrating to type on that little keyboard. And so PDAs have a natural input problem that speech is very good at solving. I'll tell you more about some of the benchmark studies we've been doing comparing the use of speech towards those on-screen keyboards later on. But roughly, we're able to double our input rates by using speech recognition in the PDA. One of the biggest problems there is input rate. Speech can really help that. The other thing that we're doing is really leveraging the multimodal nature of this interface. So we've seen a lot of speech recognition applications in telephony, just using a telephone handset as the client. There, the speech recognition is the only thing that you have to go on. One of the advantages of the Pocket PC, though, is that we've got this nice touchscreen display. And so by using mechanisms like tap and talk, where you tap in the field that you want to talk to, we're able to greatly improve our speech recognition performance by having a little bit of context that you've provided through another modality. So what can MiPad do? Email, send and read email, view your inbox, some limited searching and filtering of your inbox. We're not trying to create a new, richer mail client or something like that. We're trying to get minimum mail, calendaring, and contact list functionality into the PDA form factor. And so don't expect to be able to do everything you can do from Outlook in MiPad, but hopefully we'll get those functions that are really most essential. Schedule. We're going to start deploying this in the speech technology group in September. The builds that I'm showing you today are not quite solid enough for real everyday use. Our development milestone in September should produce builds that we're going to start using internally. By the end of the year, we're going to be deploying out to the rest of Microsoft Research. And then our hope is that by early part of the next calendar year, we're going to be available on the MS Market internal order system. So that when you do buy a Pocket PC in any of the groups, you can say, I want the MiPad bundle and have that appear loaded on it. So as a research application, the technologies used in MiPad are really initially the focus. The technologies in the user interface. In terms of the technologies, though, we're doing a lot of work on trying to improve the engine recognition performance. This is a technology called the Unified Recognition Engine. Talk about that a bit later. Doing a lot of work on noise robustness. You'll notice that on the Pocket PC, the microphone is just this little directional microphone on the front. Not nearly as good in terms of clearing out noise as a close-talk microphone, a headset microphone. And so we've got a lot of work to do to try and bring our recognition performance with this poorer quality microphone up to the level it would be with a high-quality close-talk microphone. Noise robustness. Also doing work on dialogue management. Now, the initial release of MiPad it will not necessarily make the fullest use of this, but dialogue management, I'm talking about multi-turn dialogues, so ask for clarification from the machine. It remembers what you said one conversational turn previously, can have these long extended dialogues. MiPad initially isn't going to make much use of this, but this is one of the core pieces of research in the speech technology group. And the user interface, of course, with the... Boy, this is really annoying, isn't it? Would it be better for me to turn that screen off altogether, or no? Okay. Okay. He's working on it. Okay. Working on the interaction model, trying to create a flexible interaction model, and then methods for evaluating speech user interfaces. One of the things that I did when I first joined the speech technology group was some research trying to figure out, well, how do we tell if we've been successful in creating a successful speech user interface? What metrics are there out there for judging the success of a user interface, specifically a speech user interface? Found that there weren't really any, that we need to develop some metrics, some guidelines for evaluating whether our speech user interface has been successful. And hopefully do this in a way that's applicable to the product group, so when you guys start building speech user interfaces, we've got some tools for you to evaluate how successful you've been in doing so. So MiPad's architecture. One of the first things you might be wondering about is... I asked whether we should turn it off, got a no, and then didn't turn it off, and then it went off anyway.
Okay, now it's my fault.
Good.
No, we don't know why it's flickering, so we turned it off, and it has to cycle, and we'll turn it back on. We'll see if it's better.
Good. Thanks, Dave.
Okay, would you guys rather have it off or on and flickering?
On.
Okay. That side of the room.
And that side of the room doesn't care much. So. Good. So a little bit about MiPad's architecture. One of the first thoughts you might be thinking as I talk into this Pocket PC is, how in the devil does a Pocket PC have the processing power to do speech recognition? The answer is that today it doesn't. What we're doing is building a distributed speech recognition solution so that the Pocket PC is acting as the UI logic, presenting the user interface, collecting the speech data, sending that speech data back to the server to be recognized, and then the server is sending the results of the recognition back to the Pocket PC to be displayed. So the Pocket PC is really not providing much of the processing power in this picture. The one thing that it is doing is you'll notice this signal processing box in the architecture diagram. Right now, in the prototype or in the version of the application that I'm showing you today, we're using a huge amount of bandwidth on the wireless LAN card because we're sending the raw, uncompressed audio back to the server to be recognized. Obviously, this is not a good thing to do over the long term. So what we're doing is using the Pocket PC to do some front-end processing and feature extraction so that we extract the speech features and then send those back to the server. Basically, this reduces our bandwidth requirements from well, almost the better part of 1 MBS to 2.5 to 4.8 KBS, which is really down in the range that we can fit ultimately not only on the wireless LAN, but even on a cellular modem. So that, of course, is our long-term goal with MiPad, creating a distributed speech recognition solution. It's something that's not necessarily tied to the wireless LAN, but that's cellular modem-based so that you can take it anywhere. Really, that's the primary reason that our initial release is focused internally on Microsoft, is that we can't expect anyone else to have that wireless LAN support. And so we're necessarily an internal product until we get that cellular modem work done. So we do the feature extraction in here on the client. We send those extracted features, and incidentally, just to clarify, a feature is just an acoustic unit or a unit in the acoustic signal that the engine then extracts the meaning out of. So you can think of it kind of like a phoneme. It's not really a phoneme. There are more phonemes than there are acoustic features, but it's a specific, unique sound that we're pulling out of the client end. So the client does that signal processing, does the feature extraction, sends those to the server. We then feed that to our continuous speech recognition engine. That pulls out what its best guess of the utterance was. We then feed that into a parse step, the spoken language understanding unit, where we try and take the recognized utterance, turn it into some action in the user interface. Then that jets down into this dialogue manager, feeds to the application itself. And this dialogue manager is where the multi-step conversational turn processing is taking place. Also where we're doing things like creating semantic classes. So for instance, I might say to MiPad, give me Derek Jacoby's boss's office number. Derek Jacoby's boss is a semantic class that then resolves into Zuidong Huang, my manager, and then that will be what's handed to the application to get an office number. And so this reference resolution or semantic class resolution takes place in the dialogue manager. And then the application takes that and sends some UI back to the client, or talks to the UI logic that's actually running on the Pocket PC to deliver the results to the end user.
Eric?
Yeah.
Can you talk about those, the dialog manager and the application?
Yes, I will talk about the dialogue manager and the application a little bit a little bit later on. Specifically, the dialogue manager, not so much the application APIs. Great.
Does the application actually run on the server?
The application actually runs on both the server and the client. The server side is where it ties into the speech recognition logic, and then the user interface code is actually sitting on the Pocket PC. Now, that's true in the version that we eventually release. The version that I show you today, everything is actually running on the server, and I'm accessing it through terminal server. That's a temporary development or an interim development step, though.
What kind of hardware resources?
Question back here, what kind of hardware resources do we need on the server? As much as we can get. So we get acceptable performance on a 450 megahertz machine with 128 megs of RAM. Not great performance, but acceptable performance. That's really what we're treating as our minimum configuration. I'm in the midst of building a server box we're carrying around to demos, though, that's a gigahertz class machine, and we're able to effectively use every bit of that processing power.
So is that for one client, or how many clients for that server?
For one client today, one of the pieces of work that we will have to do before going to any external productization of MiPad is figure out how to overcome that one client, one server limit and do more efficient speech server processing. But today it's one client per server.
How much of that is because you're doing the signal processing there at the moment? And how much is going to be there in the long term?
How much of the server requirements are based on the signal processing?
Because that's only a temporary requirement, right?
Right. That is, because that will be moving to the client. Unfortunately, that's not going to save us a huge amount. Most of the server resources are used during the actual search for recognition, as compared to the pre-processing of the acoustic signal. It's going to help some, but not a great deal.
So you said that you'll be able to get down to a few kilobits. What kind of overall link latency can you tolerate? Still have acceptable performance?
Yeah. we're going to be really sensitive to latency, just because any latency in the signal getting across is additive on top of the latency already present in our recognizer, and unless you've got a really fast machine where the recognition is happening in significantly greater than real time, you're going to see any latency from the channel just directly added to it, and it's going to be pretty painful. Now. That having been said, there's nothing too time critical in these acoustic packets getting to the server. We're not going to it's not going to crash on you. It's just going to slow the recognition responses getting back to your client and lead to decreased user experience if there's channel latency.
So in your work in the UI models, what kind of channel latency do you think is tolerable and still have the best alternative for this?
Yeah. The channel latency we see in the final product is going to be less than the latency caused by the amount of data we're transferring today. So anything we see in the final product is going to be an improvement over the current version of the software. So I haven't really set hard requirements saying we have to get down below this channel latency, or channel latency must be no more than this proportion of the total recognition time. I haven't set requirements like that simply because we are improving that aspect, so we're getting better. How is client battery life? Specifically on the iPack, it is not bad. You'll notice that I'm giving the first part of the talk with the iPack plugged in, letting the battery charge so I can talk to you, though. So could be improved. One of the things that's nice about the iPack is that the sleeve that the PCMCIA card plugs into has an external battery in there. So I'm seeing about, I guess about 2.5 hours, 2.5 to 3 hours of reasonable use of the thing. Yeah.
One point, when you move to signal processing, you actually should gain there because the transmission in these cards is much more power hungry than signal processing on these chips.
Yes, that's a very good point. So the transmission over the wireless LAN is a big piece of that battery. Okay. Hey, well, let me show you stuff. I'm getting tired of talking and need to show things. Okay. This is not really the ideal display of this, seeing the rest of my desktop in the background to distract there. The reason that this is, of course, in the small size is that this is simulating the size of the iPack screen. Yeah, I wish I could expand that for you, but we'll just have to pretend it's full desktop sized. So the interaction, I'm going to be clicking with the mouse on the desktop here in the same places that I would normally be tapping with the pen on the iPack. So when I click down on something, just imagine in your mind that I'm actually tapping with the pen. The other thing that you won't be able to see in giving the demo this way is that MiPad uses a press and hold metaphor when you're talking to it. So when I'm talking to the do field down here at the bottom, I'm going to hold the stylus down the entire time I'm speaking and then let it up when I'm done speaking. Of course, since the mouse is down here, you can't really see when I'm letting up and pressing down to get the idea of the interaction. So let me just start by scheduling a meeting with Peter Mao, my development lead. Schedule a meeting with Peter Mao at 3 p.m. on Friday. So you can see that in the utterance, the things that are bolded on this screen are the pieces that were picked up out of what I just said. Peter Mao was pulled up as an attendee. Friday at 3 p.m. Was pulled up. And there was a bit of extraneous noise at the end of my utterance that was picked up as a subject. Basically, the subject field is a free dictation field, so we're less able to apply tight grammars to make sure that people are really saying things that are appropriate to the field. Since it's a free dictation field, it's only allowable on the end of an utterance, so that we can't have these more tightly scripted or grammared fields after a free dictation field because we wouldn't know where the dictation was stopping, really. And so any noise at the end of an utterance is likely to get picked up as subject line stuff, is where that came from. So let's make it a schedule meeting instead. Scheduling discussion. Okay. Schedule and discussion rather than scheduling discussion. Pretty close. Of course, can go through, give it a location, any of the normal fields that you would use in scheduling a meeting. Then when you're through, right now our send is actually a UI action rather than a spoken action. We're going to be adding a spoken send with a confirmation as well. With the confirmation problem that it was most vexing there is that of all the things you want to be certain of being said, send is one of them. Forget it. Okay, let me send an email now. Send an email to Bill Gates. I have to remember I'm on a live server. I usually do it on my test server. Hey, Bill, how about this MiPad demonstration? Period. Do you like it? So one of the things that I'm always a little bit nervous giving my free dictation demonstrations as part of this because the room acoustics really affect this. The echo from the microphone, from the speakers, really affect this. There are, hey, boy. Yep, exactly.
What's it say?
It says, but felt as much administration, the alleged. Right. Yep. So one of the things that this gives me a good chance to show, actually, is what some of our correction strategies are. In this, actually, administration was going to be demonstration, and so I've got a couple of choices for correction. I can pull up the little soft keyboard. I can type in demonstration, painfully squinting. I can instead select it and redictate demonstration. Uh-oh. It's not good. Oh, wow. Let's skip this one. Send an email. Huh, boy, okay. I think we're going to have an annoying bar in front of us the rest of the time. Yeah, sure enough. Okay. Test message. Well, I didn't get anything to correct that time. Here's another message. Okay, method instead of message. So I might message. Might just hold down and say message. The other thing that I can do is, this isn't working in this build, but you'll notice this words and forms list. This is a list of words that are acoustically similar to the word that was its best recognition guess. So when I select method here, I might see that words list get populated with message, methods. Oh no, methods would actually be in the forms. Words that are acoustically similar to method, anyways. Then the forms list would be different forms of that word. Methods. I don't know. Method is a poor example, I guess, because it doesn't do things like methoding or methodology. I guess would be one of those. One of the biggest problems that we have is in forms of words, particularly plurals. The difference acoustically between method and methods is very, very small. And so that's one of the easiest mix-ups that the recognizer can make. Having the list of alternative forms of that word right there allows you to do single-click correction, which if you can click on the word in the list and not have to redictate, not have to type on the keyboard, that's going to be faster, of course. Put this back away. And then the last one that I'm just going to click to and show because it's not really operating today is contacts. The other icons that we see up on the main screen in MiPad today are really going to be going away before our initial release. They're features that we've cut in order to get out to roll this out internally this year. The one that is exciting that is going to come back is the voice browser work. We're collaborating with MSR China. And they're doing voice enabling of the browser for us, so hopefully we'll be able to roll that in sometime late this year or early next year. That's a very hard problem, by the way, guys, because of the differences in pronunciation of URLs, the range of things you can navigate to. I'm very, very excited to hear MSR China has taken on voice browser and will be delivering us something. Okay. So. The interface. This is really the part, and I'm biased, of course, since I'm the one primarily working on the interface. But the user interface in MiPad is one of the areas that I'm most excited by. The interaction model for talking to a speech recognition system is really interesting. Talk some about the social aspects of interaction. When I'm in a meeting, I'm not going to be sitting there dictating my meeting notes. But striking a balance between allowing everything to be accessed both by speech and by UI, or what things are acceptable speech-only access, what things just need to be accessed in the UI. These components of this interaction model are very interesting. Basically, what we're coming down to are some decisions along the lines that things that are configuration of MiPad can certainly be speech only because you can choose when you want to do them. The normal core product functions probably have to be accessible in both because we don't know what environment you're in when you want to write an email or schedule a meeting, so we need both UI and speech access to it. And then some things like confirmations, like that send. There's been some discussion about there not being any way of doing so through speech, just because of the possibility for making errors there and the critical nature of those errors. So the interaction model really has a number of interesting decisions there. The one that really is going to be telling on this is the longitudinal study. When we put one of these in your hands and follow you around for a month or two and say, hey, how'd it work? That's the real test of the interaction model. Question back here.
What kind of data are you going to be collecting during that longitudinal study?
What kind of data are we going to be collecting during a longitudinal study? There are lots of interesting types of data we could collect. So, for instance, we could build language models out of emails and things like that. We could build acoustic models out of your speaking patterns, get good noise data from the background environment that you're speaking in. So there are lots of pieces of data that pertain to training and improving the recognition engine that we could collect out of that. We'll also be collecting usage data. How many emails are you sending through voice? How many emails are you sending through using the stylus and pen? We'll also be providing some feedback mechanisms. One of the pieces I've been thinking about is a bad button, so that if you're using it and you hit the bad button, you can give us a quick utterance saying what was bad, what went wrong, and we'll collect that data, so knowing when there are things that are big enough problems that they were commented on. Of course, there are some balances, privacy concerns, things like that, and so we'll probably actually, when we do the longitudinal study, have several different levels of participation depending on what degree of access to your data you want to give us.
You can also get some feedback on what your customers think you ought to be tracking for, like speech tracking or speech UI guidelines and speech UI grading criteria.
I would love to have feedback on that, and in fact, when talking about ways of evaluating the success of speech user interfaces, coming up with a standardized rating scale that can be compared across products is exactly the kind of thing that I'd love feedback on.
Also, like the social norms and stuff.
Yes. Yeah, it's going to be very interesting.
How many people thought you were talking to yourself?
Yeah. Right. So in some of the preliminary benchmark work that we've done comparing the success of speech input versus pen input on the PDA, I just want to share a few numbers here. We found that roughly we're seeing twice the input rates using speech as the pen. Now, this number, I think, is actually an underestimate of the improvement we'll eventually see, and that the version of MiPad that was used in this usability study is the same one that I'm demoing to you today, and it's not quite bulletproof yet. So my little bar floating up there, that confused, that kind of thing can really confuse usability subjects. And so once we get the bugs out, I think we'll see better than these doubling. But even a doubling is a fairly significant improvement in input rates.
Derek?
Yes?
Does that doubling that you have here include correction time for the mistakes of the speech?
Absolutely. The question is, does the doubling include correction time? You really can't do measurements that don't include correction time and be able to compare very effectively.
The current version that you're using now, you still show double the improvement?
We still show double the improvement in long email tasks, including correction times. Now, the long email tasks is an important point to add there, that we saw somewhat less than a doubling of input rates on things like calendar entries and very short emails, where the actual text entry block wasn't as big a component of the task. Yeah, question here.
Are you comparing against the keyboard that you guys created specifically for this, or against the keyboard input on a Pocket PC, or the handwriting recognition on a Pocket PC?
In this particular benchmark study, we were comparing against the soft keyboard that we created for MiPad. We're going to eventually be looking at handwriting recognition in comparison to that, but for this first benchmark, we had those numbers out there from past studies comparing the effectiveness of soft keyboard versus handwriting recognition, and so we decided just to extrapolate from our keyboard. Now, what I don't know is how our keyboard compares to the Pocket PC built-in keyboard. There may be significant input rate differences there. I'm just not sure yet.
Also, is it new users or experienced users?
This particular one was experienced PDA users, but with no speech recognition experience.
Does your keyboard support, just is one difference between that and Pocket PC, does it support word completion, like on the Pocket PC?
Not effectively. Yeah. So the word completion, in fact, is one of the areas where I think the speed up there would be a speed up in the soft keyboard on the Pocket PC.
Is the recognition going to be speaker independent, or is there an enrollment process that users do?
Oh, yeah, very good question. Thanks. I should have talked to that actually during the demonstration. So we have a speaker independent model in MiPad. You don't need to train it, but you really want to train it. Our recognition results on the speaker independent model are rarely exceeding 80 to 85% in the dictation, which you can get it up to 92, 95% kind of range with a speaker dependent trained. So the training is really important. Yeah.
Are you focusing on native English speakers only, or just
we are right now focusing on native English speakers, at least in our benchmarks and usability testing, since that's what the recognizer has been trained on. MSR Beijing is, of course, doing work in Chinese as compared to English. We've seen our engine ported to several different languages, so it's certainly possible to look at other languages. Native English is currently our focus.
Would the recognition rate significantly improve if people were talking to this machine in a more recognized way? That is, if they weren't using exactly natural speech, but were like leaving space between their words?
Right. So question was, would recognition improve if people were talking in a more mechanistic way to the PDA? I was going to show you this morning an example of discrete speech. This is continuous speech recognition that I'm showing you today. Discrete speech is where you have to leave those pauses between words. Discrete speech is a much easier problem, so you can get much better recognition rates. You can use much less processor power. We can fit a discrete speech recognizer engine on the Pocket PC. But the problem is the user experience is a very painful one. It is much more trying to say type a sentence here, period, than just to say it like you and I would speak. And so the user experience is really what you give up when you go to discrete speech.
Are you going to do any benchmarks that show like the long email transcription task using voice recognition on a MiPad versus a desktop typing? Because I'd be more curious to see, is this easier than actually just typing an email on my desktop?
Right. This is one of the questions I'm quite interested in. Yes, I will be doing this in a benchmark, but in terms of the interaction model, one of the models that we've been looking at as possibility is you dictate your messages while you're running around. They sit in the queue. You get back to your desktop. You correct using a full-size keyboard on your desktop. The assumption there is that the full-size keyboard is faster than speaking and correction. But it's just an assumption at this point. I'm also going to be interested in that.
Do you have a easily comparable benchmark, like words per minute for transcription, that's useful for, let's say, just the overall email transcription task with and without correction? That way it would be easier to compare to, let's say, a Pocket PC, which someone else has probably already benchmarked.
Right. I guess the measure I'm mostly using is word per minute in the dictation. So that 2 times improvement was based on long email numbers, primarily because the bulk of the task time is spent in a dictation block where it's just a text editor, basically.
So do you have those words per minute numbers on a slide that we can see just what is your words per minute?
Yeah, I don't actually have them on a slide, but why don't you catch me right after this, and I've got them on my machine somewhere there.
Do you actually work with like Dragon Naturally Speaking and other vendors that develop speech recognition software to see what kind of metrics they can do?
Not too much, no. Mostly, I know that if I was approached by Dragon saying, "Can we have your metrics for evaluating your engine?" I'd have to scratch my head and think about it first. So I suspect the reaction would be the same.
Do you have any data that compares for, say, the same user, words per message using a desktop keyboard, words per message using just a soft keyboard versus voice recognition? And have you learned anything from that about people's habits?
Not yet. So the question is, have we gotten any data about types of email messages, words per message, length of message, type of word usage on desktop versus in MiPad versus PDA without speech? We haven't yet, primarily because we haven't rolled out to any real users yet. That's one of the things I hope to get out of the longitudinal study, though.
The current method where you have the tap and hold while you're talking isn't possible, of course, for people who couldn't tap and hold, those with disabilities.
Yes.
What kind of alternatives for local start and stop do you have for people who want to just say stop, start, whatever?
Right. We haven't done a whole lot of work on the verbal start and stop. When we moved MiPad into a more hands-free, eyes-free kind of environment, like we moved it into an auto situation or something like that, we'd have to do a lot of that. But the stylus, you run into not just disability problems with using it for start and stop, but also mobility problems. I can't start and stop that stylus very well as I'm walking down the hallway. And so one of the things that we're going to be doing to address that is using the hardware button on the iPack. So you can press the hardware button and release the hardware button when you're done talking, which requires a lot less dexterity than the stylus. I don't have a speech-only solution to that right now, though.
Is there some problem with speech detection or something that because often in command and control there's no push to talk button, it just detects when you start speaking and when you stop?
Right. That's really a command and control versus continuous speech and dictation difference. In the continuous speech, we do have end of speech detection algorithms. Have been doing some work there. But it's actually a fairly difficult problem to do so robustly and reliably with continuous speech. With discrete speech, I was talking about the accuracy of discrete speech engines. The accuracy of those engines is enough greater that we can more reliably detect the end because noise isn't going to get recognized as narrowness words there as easily as in continuous speech. Yeah.
So far, I'm seeing only speech input part using the speech recognition. Are you doing anything to do with PTS enhancing MiPad experience?
Yeah. So the question is, are we using speech for output at all on MiPad? Today we are not. Again, since MiPad is focused primarily here at Microsoft at work initially, the speed of reading something as text on the screen is enough greater than the speed of listening to something as TTS that for efficiency's sake we've left it as just screen output. As soon as we're going to an external product that might be used in a car, that might be used in an environment where you can't really read the screen as well, we'd have to add that feature. But initially we've not added it.
I was wondering if this greater accuracy for the discrete speech transfers into better benchmark for email transcription tasks.
Yeah. So the question is, does the greater accuracy of discrete speech translate into greater throughput in the email transcription? I don't know the answer to that yet. I've wondered that a bit myself, and I guess the thing that has not made that a priority to see if the discrete speech is actually better on throughput is that its subjective experience is so poor as compared to continuous speech. So it's an interesting question as whether if something that was painful to use and provided a poor subjective experience was actually faster, would users prefer it?
Well, it's dangerous to talk about subjective experience because people get proficient in what they do.
Yes.
And also, success of handwriting, for example, was first accomplished in something that was not really handwriting, where people were writing.
Relearn their alphabet, right?
So
right.
If you talk to anybody 10 years ago whether they would be willing to write graffiti or we should develop handwriting recognition as it is, everyone would say it's subjectively it's a bad experience. You shouldn't be doing it. And still it was a success.
It wasn't so well, yeah. No, it's an interesting point. Certainly there are big advantages in the technology to discrete recognizers.
I mean, perhaps you even want to consider using keywords which are easily recognizable, almost to the way of changing the language if necessary for the machine to understand it better.
Yeah, interesting approaches there. I wouldn't mind talking to you offline if you have specific ideas on how we could do that.
But in effect, the recognition performance doesn't scale that well, even with like a simple 10-word, recognition task. You can still make mistakes. All these stages of research have been gone through in the speech recognition community, and the performance of continuous speech is not that much worse than discrete speech now, I think.
Well, it certainly is in terms of processing requirements. Certainly much worse there, and actually even in accuracy, it's a significant difference still. It's not the difference it was 10 years ago, but it's still very significant. We thought, for instance, about using discrete recognition for our correction strategy, so that when we go to correction, we drop back to a discrete recognizer.
Yeah.
Well, especially if you can put it on the engine is put on the device, then it's a commercial product.
Yes. One more back here, and then I better push through some more.
Just a quick question on setting the user expectation. So on the command and control side, what's your feedback or letting people know what their valid commands are? Like when I hit tab talk, is it like what I see is what you see is what you say kind of WYSIWYG experience, or these infamous what you can say dialogue boxes?
Right. The discoverability of speech commands is a real problem, and one of the things that in creating a really compelling interaction model we have to address is that there's no way, like in a UI, you can drop down a menu and see what things you can do. In a speech UI, there's no menu like that for you. Some of the things that we're playing with is so first of all, in the initial development of MiPad, we build language models. We bring people into the data collection lab, figure out how they say schedule a meeting. Do they say make an appointment, make me an appointment, schedule me an appointment, schedule me a meeting? Collect all of the different linguistic variations for how people in general say this, trying to sample from the same population as will be using the device. And then we build grammars for these utterances. Now the problem is that the bigger your grammar, the more different things you can say, the worse your recognition is. It just increases the search space that you're choosing in here. And so allowing a user to say, well, I never say make an appointment. Why is that in my grammar? It would allow them to prune down their choices to something that improves their recognition. We're thinking that during the training wizard, when you're reading and building up the acoustic model that's speaker dependent, could also have some pages in that wizard that allow you to select preferred phrasing so as to prune down your grammar that way. Okay, one more. I've got to push through a few more slides, though.
Do you use one language model in your speech recognition system or different language models depending on the stage of the task you are in?
We use one language model or different language models depending on the state of the task you're in. So we use grammars and a language model. So in very specific fields with a specific grammar on them, there's actually not a language model in effect generally. And then in our free dictation fields, we've got a dictation language model. I don't believe that right now we are using multiple language models anywhere. It's certainly a possibility. If we found that the subject field, for instance, had a very different language model than a message body field, that would be a place we could eke out some improvement. Okay, I want to fly through a few slides talking about the technologies in MiPad, and then I want to talk a little bit about futures and how this applies to you and the product groups. Noise robustness. So one of the big things that is hard to do is to make the little microphone on the Pocket PC act as well as a close talk microphone. Some of the work that Li Deng has been leading is the ability to model the noise that's in effect in that microphone and in the environment and subtract that back out. And the thing that is amazing to me about this work is that previously match training it was as good as you can do. If you train in the same noise environment as you're going to be using it in, you can't do any better than that. Well, the adaptive training and modeling the noise, choosing the best fitting model at runtime, actually is better than match training in some instances, which I have no idea why. In 2 talks now, I've come up on this point and boxed myself into a corner where I can't explain why it's better than match training. But in the last talk, I've lost another display. Sorry. But it is. We're seeing improvements. You can see in this graph here that. maybe you can't see in this graph here. Hey. Okay. Yes. What I see on my display is a graph that has the unadapted whisper recognition rates as having the most errors. Oh, heck. It doesn't make sense to walk through this graph when you can't see it. The noise adaptive training is doing better than Matt's training. This is a good thing. This bodes well for this microphone being useful. Next slide, which you can't see. The other thing that I want to talk to you a little bit there is that today we're seeing about 5 to 6% difference, worst case, between the built-in microphone and the closed-talk microphone. 4 to 5 to 6% in there. The noise adaptive training ought to be able to significantly reduce that so that we're able to get closer to the closed-talk microphone with this built-in. One of the things in terms of user model is that while there's some question as to when it's socially acceptable for someone to speak to a PDA, there was absolutely no question as to when it was socially acceptable to walk around with a headset on or sit in a meeting with your headset on. People just won't do that. And so we have to move away from the closed-talk mic, even though that's what gives us the best recognition performance.
That's not entirely true. Because if you look at cell phone usage, you will see people walking or sitting at lobbies or just with the headset and talking to the headset.
Yes. Actually, that's a very good point, is that with cell phone use, people are starting to use the headsets more. Outside of North America, people are using headsets much more. In Europe, for instance, I think that we would find it more socially acceptable to wear a headset for talking to your device than here. But in general, in any sort of social situation like a meeting or where there's any other person around, it's just not.
Especially with the advanced Bluetooth, you'd see people with the thing in their ear all the time.
Right.
Yeah, part of the reason why using a headset now is awkward is because of the wires. So we'll probably see a jump when we go to no wires.
Yep, a wireless headset would certainly help there as well. You're right.
What would happen if you had gestures involved, for example, holding your phone in case you were talking? Things like that might make it more acceptable.
That's interesting. Yeah, there might be a use to get rid of the push-to-talk metaphor with the headset. Yeah, interesting. Okay, I guess I have one screen back. Unified engine. I'm not going to go on it at great length about this, but basically this is the next best hope for improving our recognition engine. Is that today there are separate recognizer and parser steps. They share different language models. So the recognizer comes out with a best guess saying, here's what I think someone said. Then we feed it to the parser, and it tries to go through and say, okay, based on this string, here's what I do. But this here's what I do and here's what I know is a valid parse doesn't ever feed back into that recognizer performance. And so the information about what constitutes a valid parse feeding back into the recognizer, so the recognizer basically only spits out valid parses, is going to be a way of improving the recognition. There's more data there for the recognizer to go on. Dialogue management. Talked a little bit about semantic classes here. Find me Derek Jacoby's boss's office. I've talked a little bit about conversational turns, so resolving references. For instance, where's Derek Jacoby's office? 113-2178. Schedule an appointment with him. Well, how do you resolve him? You've got to go back to that previous conversational turn and figure out that Derek Jacoby was the last person mentioned. And so we've got in the dialogue manager this concept called entity memory, where we'll take things like people, places, times, fill them in these entity memory slots, and in the next conversational turn, if someone has made a reference that can be resolved by pulling something out of there, we'll do so. And then small devices. So this is the work I was talking about fitting the discrete recognizer on a pocket PC device. This isn't really central to MiPad's product direction, since we are right now building a distributed speech recognition solution. But it is certainly important to the progress of speech recognition on small devices, because there are always going to be situations in which you can't depend on there being a wireless link, or you do have to do the recognition on the device itself eventually. And so that's what we're working towards there. I was going to show your Alex's blind source separation demo here, not because it has so much relevance to MiPad, but because it is a concrete example of the type of noise separation or noise adaptation work that's going on in the speech technology group. Can give you some idea of what kind of problems we're trying to solve with this work. So what Alex Esro here, what he's doing is working on, for instance, separating out two speakers from the same channel. So we've got this.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And so normally for a recognizer, a WAV file like this would be enormously difficult to process. You've got two different speakers saying different things overlaid on top of each other. By using microphone arrays and using some algorithms to separate out the speakers, these waveforms have been modified to
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 y 10.
So you can hear that just through algorithms and through these microphone arrays, we can really sort out different speakers, pulling the signals out to be recognized appropriately. Again, this isn't directly applicable to MiPad, but as an example of what we can do through algorithmic manipulation of audio data.
Quick question. Does that also apply when the speech is in overlap? So, like, for instance, you have, uno, dos, tres, and the English equivalent. If they were slightly, if they weren't overlapping, for instance, how well does it do in distinguishing?
Well, so I don't know that the overlap is necessarily the critical factor here. What is the critical factor, and pointed on the slide, but I ought to point out also, is that the room acoustics and reflections in the room become very, very important. And this is working in a soundproof room today, but not in a real environment yet. That's why it's really just an example of what kind of algorithmic techniques they're working on. So I would urge you actually to talk to Alex about whether the overlap is critical there. So this is really just the first step. MiPad is an internal trial. We're going to gather data about mobile device usage, about speech usage in a PDA. But it really is just the first step. We're starting to think external product thoughts for MiPad. I want to use a greater use of dialogue and context. We've talked about some of these hands-free, eyes-free situations that are very interesting to move MiPad into. And then we've talked about scaling the MiPad server up to satisfy multiple clients or to connect to multiple clients. This speech server work is one of the areas that I think we've got the most to gain. In that a MiPad speech server, the architecture we'd need for MiPad would be exploitable in many other interesting ways. For instance, a web page speech server or any other application speech server. MiPad's requirements on the server side are not that unique. And so there are certainly opportunities here, both on the server side and the client side, to take MiPad in interesting directions. Competitors, I was going to have a little bit of a external productization discussion here, talking about some of the people doing things like MiPad. Docomo in Japan is got no speech recognition in their phones, but they've got a phone system where you can do ticket ordering and buy plane tickets, rail tickets, concert tickets, whatever. That is really being very extensively used, much more so than any system here in the U.S. And so this kind of proprietary mobile device system are really the thing that MiPad would eventually compete with if it were an external product.
They might have a little trouble competing with you at the moment in that they only have one server apparently central to the system.
Oh, yeah?
So since you have like one server per user, that might be a slight problem.
That might be a slight problem today. No. Actually, I better clarify here that...
It came out recently because they crashed a few times and they had to admit that they only had one server.
Oh boy, I didn't know that. Yeah. This, of course, is longer-term stuff based on MiPad being a product. So these aren't really competitors to MiPad as an internal release, but that's a real good point before we went external.
Means you might be able to sell to them at some point because you have a more sophisticated approach than they seem to have.
Mm-hmm. Yeah. So a few notes about speech in your products. The first is that distributed speech is a different approach to speech recognition than we've tried in the past, and it would allow your products to take advantage of speech recognition without necessarily having the local processing resources to do speech recognition available. So any place that you've got a product that's already using most of its resources, but you know one of the primary usage scenarios is in a networked environment where you might be able to rely on other resources for doing speech recognition, you might want to take a second look and think, hey, would this be useful to my product? If you do find areas there where you think, hey, I'm the perfect application for a speech server, I'd love to offload speech recognition, use it in my product, I want to know about those situations because those are requirements that could feed into a speech server, and the earlier we get those requirements down, the more robust we can make our plan for building a speech server. So let me know if you think you have interesting places you could use a speech server in your product, and keep in mind the distributed nature could really put it to use in situations that haven't been possible previously. Local speech recognition is well supported in SAPI 5, and so I don't have much new to offer there from today. If you do have the processing resources locally and want to do a speech recognition solution that SAPI allows. And then finally, the shameless plug. So lots of reasons for doing talks like this. One of our goals in research is technology transfer to the product groups, and so I do talks like this even for no ulterior motive. In fact, this time I've got an ulterior motive. We've got some openings in STG. We're really expanding MiPad quickly. We're thinking productization thoughts. A great place to work, exciting technology. If you want to work here, talk to me or XD. So there's my shameless plug. At this point, I want to go ahead and open things back up to questions. Unless we answer them all. Go.
Yes, I'm wondering about turning this into a commercial product. What kind of processing power would require a DSP and what kind of
Yeah. Currently, well, in terms of dedicated DSP, I don't know. If we had a dedicated DSP available, it changes the picture considerably. There, I guess I might suggest talking either to Han or XD, but I don't know as much about the dedicated DSPs. In terms of without a dedicated DSP, we need a pretty good size machine today. This is something that.
We're talking hundreds of megabytes of RAM or 10 megabytes?
Our minimum configuration for the server side for the one-to-one relationship between a client and a server is going to be a 450 megahertz Pentium with 128 megs of RAM. That's going to be our minimum server system.
Earlier you said something about internally order a PDA
Yes.
with this. Is this something you could download and add to an existing?
It is. So the question is, earlier I talked about being able to order a Pocket PC with MiPad bundled. Is this something you can add to an existing Pocket PC? Definitely. That's what we're doing today. The idea of putting our checkbox on MS Market so it can get bundled with Pocket PC is primarily a convenience to allow us to get into more Microsoft people's hands.
How does your stuff relate to Digital Magic and our investment in Digital Magic? They've also taken the server-based voice recognition approach. So they also work on dumb codes too.
Right. It doesn't much. This is a completely independent effort from any of the General Magic investments, primarily because this is reliant only upon our own technology. It's our own speech recognition engine. General Magic's is not. And they're also their goals in the project are somewhat different. So.
Voice ML type work. Are we looking into any of that stuff instead of like SAPI?
We are looking into some of the voice XML work. Kwansan Wang is your contact. He's our representative on the W3C committee building that. So.
I was going to talk about. I was going to ask you about the server that runs the application. How is that built?
The server.
Well, the server side has got the application that's running.
Yes.
How is that built? What's the technology that are usable there? How can that be expanded to create new applications?
Okay. So the question is, the server-side technology, what is that? How could that be expanded to create new applications?
Just the speech recognition, remove the applications part.
Right. There's really nothing special about our application code. One of the reasons that we've chosen the PDA kind of content domain is that it's very easy to build email and calendaring applications on top of the Outlook object model, and that's what we're doing with MiPad, is building directly upon that Outlook object model and CDO for our application logic. And so there's really nothing special about that. We're not doing anything different on the application code side than anybody else.
The ticketing application on top of that. Custom application on top of that.
Yeah. So if you wanted to build a speech-enabled custom ticketing application, I think right now your best approach, and you did have the local processing resources available for speech recognition. Okay, so you want to build a distributed speech recognition application, taking advantage of our server side, but not the client side.
Oh, yes, the client side. Since I want to build another application.
Yes. Okay.
There's some certain work you need to also the application hook between your app logic and also the spoken language understanding part. And you will probably also need someone to host the speech recognition server for you. And you can, and I think because you are on this, you want to host your speech recognition server. So in a sense, the one business model maybe will make a server which will take the audio form, and then with the output that you can expect some kind of semantic representation in XML, and then that part you need to also, because we need to tell the speech recognition server like what type of domain knowledge you have, and then once the server host for you is like getting the output of those semantic representation.
So there's no mechanism to build those applications.
We are thinking about, but we just started. I think certainly this is certainly our view.
Right. MiPad as it exists today won't be a framework. Yeah. MiPad as it exists today won't be a good framework for building your different application on top of. MiPad in the future probably will be. I think is another way of stating Hans. For everybody else. Yeah, I had a question over here.
So is your plan during longitudinal study that you're going to use along the same ways as like the RIMs are using, where your desktop is your server for the distributed voice?
Yes. So the question was, in our longitudinal study, will a desktop machine be the server for voice? Yes, it will be.
So here's a shameless plug. How do you sign up for the longitudinal study?
Cool. In September, when we're done with this development milestone, I'll be shooting a fairly wide distribution mail ad.
Derek?
Yeah.
Is MSR planning on productizing this directly or through the Pocket PC?
Undecided, hopefully with Pocket PC.
Okay.
There's there's a fair amount of discussion. But definitely it's going to be